So today we are jumping into similar triangles and polygons. Before we do this, I want to recap an algebra topic and just see if you remember how to solve it and see where we go from here, okay? And that topic is proportions. So a proportion, if you recall, is really just two fractions that are equal to each other. So for example, 1/2 and 4/8 are the exact same thing, right? If you reduce 4/8, you get 1/2. So these two fractions that are equal to each other form a proportion. Okay. There was a whole bunch of things that are true about proportions. I don't know if you remember. One cool thing is that if you flip both sides over, it's still equal. Did you know that? So for example, if I took 1/2 and I flipped it over and got 2/1, and if I took 4/8 and flipped it over and got 8/4, it's still equal. How interesting. So as long as you flip both sides, that will always work. Another thing that always works is, remember cross multiplying across those diagonals? Look what you get. When you multiply this diagonal, 2 times 4, you get 8. When you multiply this diagonal, well, how about that? You still get 8, right? That will always happen if you have a proportion. So one way you can check if you have a proportion is to do that. Just multiply those diagonals real quick and make sure that you get the same number. If you do, then yes, you have a proportion. What we use proportions for most frequently is anything scaled up or scaled down. So a map, for example, obviously is not life-size, because if it was life-size, it would just be like the regular world that you're walking around in, right? So we take the map and we scale it down so that we can look at a large area on just a piece of paper or, what have you. Or you could do, sometimes we take things that are really small and then you scale it up. So you could do, right, if you start with a blueprint. So an architect might make a blueprint and then we scale it up and create it in real life. So all of those things use proportions. Anytime that you are making something, enlarging it or shrinking it down, but you don't want it to be skewed, right? You don't want it to, have you ever taken an image and then you can change the size by like pulling on the corners? So you could make the corner you could squish it in, make it really narrow, and then like your face gets all squished, or you could stretch it out and your face gets all wide. But if you do it on the diagonal, it usually keeps your proportion. So it still looks just like you, just either smaller or bigger. You know what I mean, right? When you take those images and you change it around. Yeah, so if we want to keep a proportion, we want to make sure that we stay within these limits. So say I had, I don't know, say I was creating a map and I had something that was, I don't know. I have an area maybe that's 2 miles by 4 miles and I want to shrink it down into a map. I need to maintain the proportion. So if I know that I'm going to put it on a piece of paper and it could only be 10 inches tall, I could figure out, well, how wide would it have to be to maintain that proportion? Okay, so let me just ask you, do you remember how to solve something like this? We'll start off easy. So how do you solve something like x over 7 equals, oh, I don't know, 10 over 15, whatever. I have no idea if this is going to come out nice. Probably not. I don't think so. But do you remember how to solve a proportion like this one? Yes, I'm getting some answers in the chat. So go ahead and try this. Get me a final answer. If you need a calculator, that's fine. Suppose I should get my own answer here. Yeah, of course I picked one like this. Yes. Yes, Olivia, I will wait. Yes. Okay. So whenever you have a proportion, because the product of the diagonals is equal to each other, if I'm missing any of these four numbers, it doesn't matter which one it is, I can find it by multiplying those diagonals. And then I have an equation where I can solve for the missing number, right? So it doesn't even matter which diagonal you multiply together first. Who cares? I just usually do this one, but it really doesn't matter. 7 times 10 is 70. And then sometimes kids mess up here because they don't know, like they make a new fraction or something. I don't know. You're just it's just equal to each other. So you multiply this diagonal, and then you're going to multiply this diagonal. X times 15 is just 15x. You make a new equation. That's what we're doing here. You don't make a new fraction. You just multiply the diagonals, set them equal to each other. And now I have an equation where I can go ahead and solve for x. So I'm going to divide both sides by 15, and I should get my answer that way. So come in here, divide by 15, and 70 divided by 15 just so happens to be 4.6 repeating, or 4.7 if you're going to round. Okay, let me give you just one more to try to make sure that you remember everything. You got to remember it with proportions. Let's do 9 over 12 equals 4 over x. Try that one. Oh, look good with me picking the weird ones. Olivia, that looks good. Yes, these are all looking pretty good. Kira, just be careful in the rounding. But yes, so again, I'm just going to multiply my diagonals. It doesn't matter which diagonal you do first. Who cares? It's totally up to you. So I don't know, 9x this time, and then 12 times 4 is just 48. So there's my new equation, and then I'm just going to divide both sides by 9 to get my value for x. And 5.3 repeating. So if you round that one, it's actually going to stay 5.3, right? Because you wouldn't round up unless you had 5 or up. Okay, so I know maybe you're thinking, what does this have anything to do with triangles? It has a lot to do with triangles. So did you know that there are such a thing as similar triangles? We have talked at great length about congruent triangles. Side, 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 angle, 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 side, hypotenuse, leg, all that whole chapter, that was all about congruent triangles. Those were triangles that had the exact same shape, exact same size. All right. So today we get to start talking about similar triangles, which are going to, let me just make you a pair of similar triangles real fast. Yeah. I'm going to take the easy way out and just do equilateral triangles, but you could do them with any kind. You don't have to be equilateral. It's just easier that way. Oh, here's Lyric. Lyric, hello. I am just making similar triangles, but I'm going to pause that to go update your attendance real quick. Lyric, here we are. Okay. Am I still working? Yay! All right, good. So here are two similar triangles. So basically, it's like a shape and then the exact same shape, just miniature. So what similar triangles are going to have? Obviously, they don't have all three sides the same length as each other, right? So these are pink, these are green. They are not the same lengths. So I don't have sides that are the same, but what I do have is all the angles the same. And even if these weren't equilaterals, it still wouldn't matter as long as maybe I'll just draw them. Sometimes if I draw it, it'll be better. So if I have one triangle like this, let's say, and then I had the same exact triangle just shrunken down, we can refer to these as similar triangles as long as all three angles are going to be the same. So in other words, those angles would have to measure the same. So if one's 30, the other one has to be 30. These angles would have to match. So I don't know, that kind of looks like a 90. Maybe it's 90, maybe it's not, who knows? But in those two triangles, they would have to be the same. Now I get lucky here because if these two angles already match, doesn't the third angle automatically have to match? Because they have to add up to be 180. So I can really just look to see if two triangles have two angles the same. If they have two angles the same, that means that they have to be similar. I don't even have to bother checking the third angle, but you could if you wanted. All right, so let's put a big star because this is sort of a very important topic here. So similar triangles. And it's actually not even just limited to triangles. So let's say similar triangles or polygons. You can do this with things that have 4 sides, 5 sides, 15 sides. It doesn't matter. So what are they going to have? Similar triangles or polygons will have all of their angles exactly the same as each other. That will always be true. The angles will match perfectly. All three will match up with all three. Okay? But the difference now is that the sides are not going to be equal, but they will be proportional. So what that means is that, let me move this down a little bit and I'll draw you another pair. I can take two sides of one triangle and match it up with two sides of another, and they will always form a proportion if the triangles are similar. Okay, so let me draw you two triangles here. Say we had that one, And let's say we had this one. All right, if I want to tell you that these two triangles are similar, the easiest way for me to do that is to use the symbol for similar. Guess what it is? It's just a squiggle, like that. Just that squiggle right there. Let me make it a little bit darker. How neat. So if you see that symbol, that just is our symbol for is similar to. So now I know that these two triangles are similar. So what I can do is, if I know that the bottom of this thing is 10, let's say, and this side over here is, I don't know, 4, whatever, nothing's drawn to scale, obviously. And then if this side here was 5, and I was trying to figure out the length of this side, I can set up a proportion to do that for me. Okay, so remember what a proportion is. It's just two fractions that are equal to each other. How you set up that proportion is actually kind of up to you. The only thing, you have to be consistent. Okay, so what I mean by that is, if I did, usually I stick with one triangle first. So if I do something like 10 over 4, I just have to do the same thing for this triangle. I'd have to do 5 over x. You can't flip-flop and change how you're doing it. So if I did 10 over 4, I would just set it equal to 5 over x. You didn't have to do it that way, though. You could have done it another way. You could have said, well, how about if I do 4 over 10? That's fine. It doesn't really matter how you set up your first fraction, as long as you do the same thing with the second fraction. So if I did 4 over 10, I'd have to do x over 5. Some people even like to match up sides instead of pieces of the same triangle. So they might do something like this. Big side of this one to big side of this one. So that's 10 over 5. And then they'll do small side of this one to small side of that one, 4 over x. It's totally personal preference. And the reason why it really doesn't matter, you could have come up with any of these three. There's even more. You could have done more than this, but I'm not going to do them all. But check this out. When I go to solve any one of these three, look what I'm doing. Aren't I just multiplying the diagonals? So here I'm going to multiply 4 and 5 together, and I'm going to multiply 10 and x together. And it doesn't matter which one I do first. One of them is going to be a 4 times 5, and the other will be a 10 times x. Look, in this one, here's the 4 times 5, here's the 10 times x. In this one, here's the 4 times 5, and here's the 10 times x. It doesn't matter as long as you were consistent. All right, here's what you can't do. Don't even write this down because I'm going to cross it out as soon as I'm done. If you did 4 over 10, you can't then, see how I did the short side to the long side? So you, over here, you have to do the short side to the long side. If you now change it up, though, and do, oh, well, I'm going to do 5 to x. You're changing it. And now, look, this would not work. You would get the wrong answer because look at what I'm multiplying now. 4 and x and 10 and 5. That's not what it was supposed to be. It's supposed to be the 4 and 5 get multiplied together and the 10 and x. So this is not a correct. You could not do one like that. But you're not going to get ones like that as long as you are consistent. So however you set up the first fraction, just do the same for the second fraction. Sometimes you even get lucky and you can do it in your head. This particular one, you can do in your head. You don't even have to write a proportion. What? How? Because look, 5 is half of 10. That means that this has to be half of that. Sometimes you get lucky. Sometimes you won't be able to do it in your head because it won't be so nice as, you know, because like what if I had made that a 7, right? then you'd have to do the math out. But sometimes, yeah, you do get lucky and you can just get your answer real fast. So what's so neat about this is that this works for not just triangles, but any, I mean, well, let me give you a couple of triangles to try before I start throwing in other things. So let me just mark, this is, we are in A block. Okay, let me give you a couple to try. Okay, how about I'm going to try and trick you with some of these as well. So first of all, make sure that you know that they're similar. They'll either have to be marked or they'll have to have two angles marked the same, or it would have to say in the directions like these are similar triangles, blah, blah, blah. Anyway, so let's say this time this was 6, this was 5, this was 4, and I wanted you to find out what that was. I'm going to give you a couple triangles. So here's set triangle number 1. And try this one. Ooh, I just thought of a good way to trick you. But I'll start off without doing that yet. That's a good one. Oh, this third one. This one's tricky. Or maybe not. I don't know. All right. Try these 4 if you haven't already. Let me see what's in the chat. Here, those all look good. Yes, Kira, they're right. At least I think they are. I honestly didn't do all of them out, but I'm pretty sure that you are spot on. Okay, so I want to sort of try to start piecing through some of these. One thing that you can always do to make sure that your answer is correct is just see if it makes any sense. Before I do anything for number 1, I notice I have the big triangle here and a smaller one here. If that was 5, and this is the same piece just in the smaller triangle, this should be something smaller than 5, right? That only makes sense. Another thing, if I look at these, this side is bigger than this side. That means the same thing has to be happening in my smaller triangle. This side has to be bigger than this side because it's the same exact triangle, just shrunken down. So before I do any math, I know that this thing should be less than 5, but also less than 4, right? It's got to be smaller than that one. And since this is bigger than this, this must be bigger than this. So I'm looking for an answer that's less than 4. Okay, so if I were doing multiple choice, for example, anything that's not less than 4 is already gone. So you might even get lucky and not have to do a ton of math. But I love doing math, so let's do it. So it's up to you how you set up your first fraction. That's totally up to you. I'm just going to do 6 over 5. And if I do 6 over 5, how do I have to do the other side? If it's 6 over 5, it's got to be what over what on the other side?
4 over x.
Yes, it's got to be 4 over x. And now I'm just going to cross multiply. So 6 times x is just 6x. 5 times 4 is 20. And then I'm just going to solve my equation here. Divide by 6, divide by 6. So what's that? 3.3 repeating? Is that right? Yes, 3.3 repeating. So that makes sense. I knew it was going to be less than 4. So that's great. Now, I tried to trick you in the second one, so I'm going to move in on this a little bit. I tried to trick you because I drew the triangles pointing different ways. Okay? Now, it's up to you how you want to handle this. You could take one of the triangles and redraw it so that they are both going the same way. If you want to do that, that's totally fine. If you don't want to do that, that's okay, but you got to be really careful when you place everything. So if I do 10 over 8 for the first one, now don't just willy-nilly go to the next one. This one's not that bad to see that, yes, it should be 6 over x, but it's worth taking the time to say to yourself, okay, well, look, use the markings in the diagram, too, to sort of help you. This one is across from the 90-degree angle. So on the other side, I want to make sure that I'm starting with the side across from the 90-degree angle. So 6 has to be in the same spot that 10 is in, right? 8, that's on the side that's in between the 90 and the one angle that's marked. So who's in between the 90 and the one angle that's marked? It's side X. I know in this diagram it's relatively easy to see, but it's not always. Sometimes it's kind of tricky and it's sort of hidden. So let's talk about this answer before I do any math. This side should definitely be smaller than 8 because this is my smaller triangle. And if this side is 8 in the bigger one and I shrunk it down, it should be something smaller than 8 for that reason. And then let's see. This side's bigger than this, which means this side has to be bigger than this. So not only am I looking for something less than 8, I'm looking for something less than 6. Because I know it's got to be smaller than this one. So when I do this math out, if I'm not getting something less than 6, it doesn't make sense. Something's not right. So let's cross multiply. 10 times x is just 10x. 8 times 6 gets us that 48. And now I'll just divide both sides by 10. So I get 4.8, which sounds very reasonable because I knew it had to be less than 6, and it is. So pretty satisfied. So if you got 4.8, good job, even though that was not drawn pointing the same way. Now, I tried to trick you in number 3, but it looks like those of you that gave me answers anyway did not fall into my trap here. Oh my gosh, with this thing. There we go. That's a little bit better. So x, you'll notice, so first of all, I drew the triangles kind of inside of each other, right? I had the original big triangle and then another smaller triangle right in here. So the two triangles are similar to each other. They both have this angle in common. And then I marked that this second angle is the same. So yes, I do have similar triangles. If it helps you to redraw the triangles separately, then you can absolutely do that. So if you want to just redraw the picture with just a big one and then just a small one separately, not intertwined within each other, you could do that. Do you have to? No. And this time, I'm actually going to start with my smaller triangle because I can. Check this out. If I look at the smaller triangle and I did 3 over 6, so I'm doing sort of the left-hand side of the triangle to the bottom of the triangle, left-hand side to the bottom. So that would be 3 over 6. I just need to do the same thing for the big triangle. So I did left to the bottom. So I'm going to do the same thing. The left-hand side of the big triangle is x. But now you have to be very careful. The bottom of the big triangle is not 2. Right? 2 is not the bottom, the whole bottom of the triangle. It's just that little part. The whole bottom of the big triangle is 8. So you'd have to have an 8 right there. And that should get me a correct answer. So this may not be the exact same proportion that you came up with, but you shouldn't have a 2 in your proportion really anywhere. Because the 2 is not a full side of a triangle. It's just this little piece. I need it to get the full side. But just this piece, I'm really not going to do anything with that. Okay, I hope this makes sense. So now before I do my math, let me just talk about a reasonable answer here. So I have my smaller triangle. So if I'm going to enlarge it to this bigger triangle, if this side was 3, that means this side should be bigger than 3 now because that's the same side. I just made it bigger. So I'm looking for something bigger than 3 for sure. So let's go ahead and cross multiply and see what we get. 3 times 8 gets me that 24. 6 times x is 6x, obviously. And then I just divide by 6. So this time it actually came out nice. And I get 4, which makes sense. I was expecting something bigger than 3, and it is. Another thing you could have done, if you happen to notice that 3 was half of 6. Did you notice that? That means over in this one, I'm going to have to maintain that same thing. This number will have to be half of the entire bottom. The entire bottom is 8, so that means this one's got to be 4. Oh. How nice. Okay, and then I gave you one more where I tried to trick you here, but you guys are too good for me. So here's 2. I kind of drew them back to back. So again, they're not pointed the same way. So you can redraw it so that they are pointed the same way, but you don't have to. So if I do big, so I'm going to do the hypotenuse of the big to its short side. So if I did 6/2, I just need to make sure that I do the same thing on the other side. Whoops. So if I do 6/2, that means on this side I'm going to have to do x/1. But again, you could have done whatever proportion made sense to you as long as you are consistent. All right, cross multiply, you get 6 = 2x, which means that x is just 3. Hooray! Oops, sorry. And that makes sense. I was taking my big triangle, shrinking it. You notice that, oh, excuse me. Oh, I'm still on weekend time, right? 2 is 1/3 of this number. So the same thing has to be happening over here. If I take this and I multiply by 3, I get this. If I take this and multiply by 3, well, what do you know? I get my answer. Wow. Now, just a thing that I want to point out to you. Whenever you're dealing with proportions, it's all multiplication and division. You're never adding, subtracting. So you could never get this answer, for example, by adding. So someone might try like, oh, well, if that side's 2, to get to 6, I would just add 4. So why don't I just take this side and add 4? No, because that would now get you 5, and we just found out that the right answer was 3. So why doesn't that work? Because when you add a set number, you've changed the proportion completely, right? Imagine taking, I don't know, I'm trying to think of like a good example of. Okay, say say you get one question wrong on a Fast 5, right? One question wrong. Since there's only 5 questions, it actually kind of counts a lot. It brings your average down 20% if you get one question wrong. If you took a 50-question quiz and got one question wrong, it doesn't have the same effect, right? So if you took a set number off, the effect is going to change completely. So if you add or subtract numbers, it doesn't work that way. But if you multiply or divide, now you've kept it proportional. I don't know if that makes sense. So yes, you want to be thinking everything in terms of multiplying and dividing, not adding, subtracting, because that's really not what we're doing here. All right, now we just want to talk briefly about how this sort of ties in with polygons. And it's actually pretty easy because it's the same idea. So if you had 2 similar polygons, all right, say I had these 2 random polygons. I knew that the angles matched up. The only thing I'm going to tell you is, let's try this. What if I told you this was 3, 4, 2, and this was, I don't know, 2x. All right, say you had something like this. And you were going to try, you're trying to solve for x over here. You're trying to solve this proportion. Well, watch this. Now, proportions, it's only one fraction equal to one other fraction. I'm not going to make 3 fractions or 4 fractions. It doesn't matter how many sides I have. I'm only going to ever really care about 2 at a time. So you could set up something that was like 3/4. But over here, then that would mean you're doing this over 2. And I'm not trying to find that side. So I'm actually not even going to bother with the 3 at all. Sometimes they're going to give you extra information. So sometimes I have to know what numbers to just ignore. I don't need that. The 3 is not really going to help me here because I don't have anything for this same side over here, and I'm not trying to find it, so I don't even care about it. So if I ignore the 3, then I can see, oh, okay, well, I could do 4/2, and then I can do 2/x. As long as I come up with a proportion that only has one variable in it, I can't have more than one variable at a time because then I won't be able to solve it. So when you're setting up your proportion, just find one. 4/2 equals 2/x. That only has one variable in it, so I should be able to solve for it. So I'm going to go with that. 4/2 equals 2/x. And now I can just solve. You probably already know the answer, though, because you're looking and you're like, oh, if I do 4/2, I'm just dividing by 2. So I'm going to do the same thing here. Divide by 2, and I get 1. But if you do add the proportion, you will see 4x equals 4. So, yeah, you get 1. No matter how you slice it. Okay? Let me give you one more like this, and I'll let you try this on your own. And then we're going to talk parallel lines real quick, and then we'll be done. Let's do some trapezoids. Why not? Okay, so we've got similar trapezoids here. And let's say I told you this was, oh, I don't know, 2, 6, 3. And then over here, I wanted you to find x 1. Try that. So I've given you some extra information that you don't need. So you need to write a proportion that has x in it, right? Because if it doesn't have x in it, then you're not solving for it, so that would be pointless. But that still makes sense here. Kira's got the right answer. Olivia's got the right answer. Haley's got the right answer. I noticed that I have the same group of people that send me their answers. I don't know what the rest of you guys are doing. Probably not the work. I don't know. I hope you are. Remember, we got a fast 10 on this tomorrow. All right. So it's up to you how you set this up, but let's just look. If you try to use this side that was 6, if you come to this one, you don't have anything for that side, and you're not trying to find it. So you know what? I'm not even going to use this one. I'm going to ignore that. I will need to use this 3 because this 3 matches up with this x. Okay, so in fact, that'll be one side. 3 is to x as, okay, great. So I did one side here to one side here. The only other side I have is this one, so I'm going to have to do 2 to 1. You may not have come up with the exact same equation that I did, but whatever proportion you created, you should have 3 times 1 on one diagonal and 2 times x on the other diagonal. That's really your only kind of option here. So you might have flipped this around a little bit, but we should be multiplying 2 and x together to get 2x. And 3 and 1 gets me 3. So 3 divided by 2 should be 1.5 is my answer. So if you got 1.5 as an answer on this, you are good. Okay, the last thing I want to talk about briefly is just parallel lines and how that kind of comes into play, but they're kind of super fun, I think. So check this out. Turns out if we have 3 or more lines cut by transversals, parallel lines, I should say. So let's start by noting that all of these are parallel lines. Okay, so let's go ahead and cut them. I'll use a different color here. When you have this sort of scenario happening, this is so cool. This is something called the side splitter theorem that lets you basically take just these pieces and form proportions with them. So watch what I mean here. Can you see how if those lines kept going, it would basically just form triangles, right? Like if these lines kept going, they just crashed into each other, then I just have a whole bunch of series of triangles here. And what happens is that all of those triangles are similar to each other. So what I get to do is I get to kind of ignore all of the other pieces and just look at the pieces in between the parallel lines. And it turns out they are going to be proportional. So watch this. If this was 3 and this was 4 and this was 5 and I'm trying to figure out what this is. I know you're like, well, wouldn't it be 6? No, because remember, it's all based on multiplication and division. So check this out. If you had a scenario like this, all you have to do is you're just going to follow those transversals and put those pieces into a proportion. So in other words, I'm going to do 3 over 4 equals 5 over x. That's it. It's just that easy. And now I just solved that proportion. And as we can see, it's not actually going to come out to be 6, but 3 times x is 3x. 4 times 5 is 20. Divided by 3. 20 divided by 3, we said was what, 6? Is that 6.6 repeating? It sure is. Isn't that neat? Let me zoom out so you can see the whole thing. So if you have parallel lines cut by transversals, you get to just make those proportions just like that. It's so neat. Okay, let me give you one to try on your own. So 3 parallel lines here. And I'm trying to draw it so that it looks a little bit different, so you can sort of just get used to having different styles. So maybe I do something where this is, I don't know, 2, and this is 5. Obviously, nothing's drawn to scale. I want you to find that if this piece is 8. I don't know. Try that. Yeah, so everybody answering 3.2. Is it 3.2? Yes, yes, you're all right. All right, so I might just do 2 over 5, for example, and set that equal to x over 8. Cross multiply, you're going to get 16 equals 5x, and then just divide both sides by 5. And yes, that's 3 1/5, so that's 3.2. Sounds good. Okay, the only other thing that you might encounter is if I just sort of extended it to a triangle. So if there's my parallel line still, and then the same thing happens with the sides of the triangle. If you do pieces of the side, you can still use this side splitter. So if this were, I don't know, 3 and that was 4, and this was, I don't know, 6, and I'm trying to find that. So you can still just go down the slanted sides and set up a proportion. So I might do something like 3/4. Oh, I didn't write 4 at all. 3/4 equals 6/x. All right, that's not the only proportion, but if you just go down the slanted sides, the sides of the triangle, and set up your proportions, you'll never get that part wrong. Okay, things get weird when you start throwing in these other pieces. So the parallel parts don't kind of work the same way, but with side splitter, we can always do the sides of the triangle this way. All right, so we cross multiply. I get 3x equals 24. Divide both sides by 3, and in this case, x is just going to be 8. Okay, does anybody have any questions right now? Anybody? All right, so let's see. Your homework tonight is on CUDA. So give me a second. I'll make it live. I will also do a couple out for anybody that wants an example of some. Oh, let's see here. Just okay, you guys are oh, for the love. Would you get out here? Do you guys ever have this? Like you're this, I don't want to say it again because it's going to talk to me. Colin, what's up?
Question.
Yeah.
Is Mr. Dial a good teacher?
He's a great teacher. Don't tell him I said that.
I won't.
Do you have him next semester?
Yeah. I'm kind of scared.
Oh, don't be scared of him.
Oh, you think so?
You know, you guys need to feel really bad for my entire. Oh, is that Mr. Dion right there?
I was setting you up. My next question was going to be, is Mr. Dion good looking? But I didn't want to hear the answer to that.
Yeah, you don't want to hear that.
Well, I knew that. I didn't catch your lesson, so I was going to have him ask you a really hard math question relative to that.
Oh God.
I had to borrow one of your whatever the things are called. What are those things called?
Oh,
yeah. Tablets. Thank you. Obviously, I'm not very bright.
Well, you just live in another time.
I do live in another time.
Yes, you still getting those paper paychecks?
I still do. No, they made me get direct deposit.
I know, dragging you into the 21st century.
So you got to similar figures for a couple of days?
Just today.
Okay.
Tomorrow I'm already moving on to, tomorrow we're doing areas of triangles, parallelograms, and trapezoids.
Nice.
I'm highlights of the last 4 chapters. That's all I have time for.
Nice. Yep. All right, have fun.
Thanks, see ya.
Yeah.
All right, this is going to be homework 24. And give me 1 second to just click it live. It's not yet. So my entire C block, they don't know this yet, but they all have me next semester. Oh, those poor kids, right? Oh my gosh. They are not going to be happy when they find out. Oh, well. Okay, here we go. Oh yeah, I want to give you that. And let's see, let me just make sure that I click the right button here for you guys and make it due on the right day. Okay, I think that looks good. So if you hop on over to CUDA, you should see homework 24. They have me because they are Algebra 1 Part 2, and they're all going on to geometry, and I am teaching only geometry next semester. So they're all moving to the next class, and I'm it. So I mean, it makes my life easier because that's one whole class less of students that I have to learn their names. So I'll already have like 20 names down. Oh yeah, I was gonna do a couple of these for the video. I forgot. So if you need to listen to me do this part, you can. If you are good, then that's fine as well. Oh, no, never mind. We are out of time. But it should be pretty straightforward. You just have a few that start off with proportions, and then I just ask you the questions from there. Yeah, just find the missing side. Just be careful if I give you, there might be some that have extra information. So don't feel like you have to use every single side. All right, that should be good. All right, guys, have a great day. Thank you so much.